Welcome to the part 2 of my second video, Circuit Basics. We're going to be talking about parallel circuits now. In the previous video, we talked about series circuits and faults around series circuits. In parallel circuits, it's a little bit different because it's not just one wire. Parallel circuits are one main circuit, but they have multiple sub-circuits involved with them. Not necessarily two like you see in this picture here. They can have like 3, 4, 5, 6, or as many as they want. Now, in this parallel circuit, how would resistance be calculated? We have two 4 ohm resistors in parallel. Would resistance be doubled? No, resistance would not be doubled. It would actually be halved if both resistors are the same value. So because we have two resistors, and I'll explain this in a moment, because we have two resistors, both being 4 ohms, the total resistance, or sometimes characterized as R total, would equal 2 ohms. If you remember when we talked about amperage in the previous video with that short right before the resistor. Let's see here. This one here. When we talked about it, we were talking about this no longer being a series circuit because it now has another option of current flow, which is acting as another circuit. And you know how I said the only thing that changes in this is the amperage? That's exactly what's happening here in this. So the amperage changes. We have 12 volts flowing. The amperage is going to get split in between. It can't be the same amperage. The amperage gets split in between the two circuits, and it comes back and flows at the same amperage coming out. So amperage gets halved, and if you think about it, if resistance gets halved for total resistance, that means amperage is double. And what that means is the amperage here is double to the amperage going across this circuit. To calculate the amperage for this, because we have our total resistance already, we can take our 12 volts, divide it by 2 ohms, and we know it's equal to 6 amps. To figure out the amperage on each side, if we take 12 volts divided by 4 ohms, we are going to get 3 amps. So we can see the amperage gets halved. So we have 6 amps here. Then we have 3 amps, 3 amps. Then we have 6 amps. That's why, because amperage gets split evenly, the resistance in between gets halved when you have two parallel circuit resistors. Now, I don't want to get into this too much right now. In our CAN bus networks on a heavy duty truck, we have what's called terminating resistors. And basically, in a communication network, they put in two resistors on either side of a big long parallel circuit, and those resistors absorb noise or unwanted signals being sent back and forth between computer modules. I'm not going to explain too much into that. That's a topic for another video. I just want you to know parallel resistors are always going to be half if they're the same value. So your total resistors on a terminating resistor on a heavy duty truck are 120 ohm resistors. But when you're actually checking the circuit, you're going to only see 60 ohms of resistance. Let's look at some faults with parallel circuits. We have 12 volts. That's our battery. We got two 4 ohm resistors, but we have an open here. How will that affect the circuit? And what would the total resistance be in that circuit? Well, essentially what we're doing is we're cutting off this circuit. Current's not flowing through that circuit. All the current is flowing through here. So now this parallel circuit is essentially a series circuit. which would mean our total resistance is this 4 ohms. So we're sitting at 12 volts with 4 ohms, which would give us 3 amps. That would be our total amperage across the circuit. And because it's now a series circuit, it's 3 amps everywhere along this wire. It doesn't get split like it did in this parallel circuit. Now let's look at something a little bit different. It's not always so easy. Like, we're going to have to make some assumptions here. We're going to make an assumption that this short that's halfway through this is going to act as a 2 ohm resistor on this side and a 2 ohm resistor on this side. With this short in a parallel circuit, essentially what we're doing is there's not going to be any current flowing this way. Most of the current's going to flow this way. And we have still current flowing this way. I basically erased this invisible side wire that was no longer getting used because of the short through the resistor. Because now the resistance is halved on this one circuit, the values are no longer the same, which means we can't use the same means of just halving the resistance to get the total resistance in this circuit. What we have to do now is use a formula. The formula is 1 over RT, which is resistance total, is equal to 1 over R1, which is equal to our 2 ohms, plus 1 over R2, which is equal to our 4 ohms, which would equal basically 1 over 2, which is 0.5, plus 1 over 4, which is 0.25, which will give us 0.75. Keep in mind, this is still over 1 over RT, so we have to inverse 0.75. And to do that, we're on our calculator, we just take 1 divided by 0.75, and that will give us a value of 1.33 repeating. That is our RT, our total resistance. It's going to be a little more tricky now because now we're not using whole numbers for quick calculations. So that is our resistance total, which means 12 divided by 1 point, oh, what's going on here? 1.33 is equal to, let me just grab a calculator here real quick. Multiplied by 1.33 equals 9.02 amps. So that's the amperage coming through here is 9.02. But also, if we take 12 divided by 2, it'll give us 6 amps. If we take 12 divided by 4, it'll give us 3 amps. 6 plus 3 equals 9 amps. And the 0.2, we're not going to worry too much about, just rounding. But that's our total circuit amperage. We can calculate how much amperage is going through each side. So we know that we only have 3 amps flowing through the circuit that was normally supposed to receive, if they were both 4 amps, they were both originally supposed to receive 6 amps. Because if they had two 4 ohm resistors in parallel, that would be equivalent to 2 ohms total circuit resistance. Then 12 divided by 2 is equal to 6. Okay, now let's try another one. What I have here is a parallel circuit that has 3 separate circuits on it, and we're calculating it the same way we calculated the one over here. The way we're doing it is with this formula, 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So first, let's do 12 volts divided by certain resistance. It's going to equal our total circuit amperage. So we would take 1 over RT is equal to 1 over 2, which is 0.5, plus 1 over 4, which is 0.25, plus 1 over 2 again, which is 0.5, equal to 1 over 0.5 plus 0.25 plus 0.5 equals 1.25. 1.25, 1 divided by 1.25 is equal to 0.8 ohms. So that's our total circuit resistance is 0.8 ohms. To calculate 12 divided by 0.8 would give us a total circuit amperage of 15 amps. So we have 15 amps coming in. That gets split between 3 different circuits. 12 divided by 2 equals 6. So we have 6 amps here, 6 amps here, 4 amps. 12 divided by 4 equals 3 amps. So we have 3 amps here. 6 plus 6 equals 12, plus 3 equals 15 amps. As easy as that. Now let's look at this example of high resistance. So, do you remember what we do when we have multiple resistors in series? We add them together. So in this circuit, what we actually have, we have our 12-volt battery, and it's supplying a 8 ohm resistor and a 4 ohm resistor. Should have probably drew some squiggly lines in there. And now we're going to do another circuit calculation because it's not the same. So we're going to go 12 divided by our total circuit resistance is going to equal our amperage, which for total circuit resistance, we go R total is equal to 1 over 8 plus 1 over 4, which this is 0.125 plus 0.25, which give us an 1 over 0.375. And just to check with the calculator, that would be 2.66 repeating. So we have 2.66 total circuit ohms. And to calculate, we would have 12 divided by 2.66 will give us an amperage of 4.5. Now, just to double check, would take 12 divided by 8 is equal to 1.5, and would have 12 divided by 4 is equal to 3. Adding 3 plus 1.5 will give us 4.5 amps. Is our total amperage, and our total resistance was 2.66 ohms. Now let's talk about series parallel circuits. Series parallel circuit is exactly what it sounds like. It's a series circuit and a parallel circuit combined. You see the series part of it, you have the resistor at the very beginning in line, and then you have the parallel after part. The parallel after part needs to be calculated first in order to calculate total circuit resistance. We know that if we have two resistors of the same value in parallel, the total circuit resistance of that parallel circuit is exactly half. So we know that that's 1 ohm, and then this is a 2 ohm resistor. With series circuit, we add resistors together. So we would have a 2 ohm plus a 1 ohm resistor will be 3 ohms total circuit resistance for this. To calculate the amperage, we'll just take 12 divided by 3, give us 4 amps. I was doing that a little weird. Um, Now let's see some faults with this, for example. You see this one has an open. It's an open right there. which would mean that this parallel circuit doesn't get used, which means we just have a standard series circuit with two ohm resistors. So 2 plus 2 equals 4. 12 divided by 4. Sorry, this is your ohms. And then 12 divided by 4 equals 3 amps. So we have our 3 amps, and we still have our total, our RT is equal to 4 ohms. I'm trying to speed this up a little bit. I'm trying not to speed too much through it. You should kind of understand the basic concepts of a series circuit and a parallel circuit. And basically, you're just putting them together. With this one, now you have a unwanted resistance on this side of the parallel circuit, which would mean that for that parallel circuit, you're just going to add it up. Same thing with because this is in series. This resistor is in series with this resistor. So this is all of a sudden, cross this out, this is a 3 ohm resistor. You have a 3 ohm resistor and a 2 ohm resistor in parallel. So you're going to do your calculation of RT, 1 over RT is equal to 1 over 3 plus 1 over 2. 1 over 3 is 0.3, and then 1 over 2 equals 0.5. Add those together, you get 0.83, and then you'd need to go 1 over 0.83, which would give you 1.20. Now, this is your total ohms of resistance, but we still keep in mind that it's a series parallel, so we still have to add this bad boy. 1.20 plus 2 gives us 3.20 ohms total circuit resistance, which would mean to calculate the total amperage through this circuit, we take 12 divided by 3.20 ohms, which would give us 3.75 amps. And how much amperage is flowing into each side of the parallel circuit is where things get tricky. To calculate how much amperage is flowing into each side of the parallel circuit, first you must calculate the voltage drop across the first resistor. To calculate the voltage drop across the first resistor, we multiply our 2 ohms of our first resistor by 3.75, which is our total circuit amperage, which will give us a value of 7.5, I believe. Let me double check. Yeah, 7.5. And that is the voltage drop across that resistor. So what we need to do is take our 12 volts minus 7.5, which will give us 4.5 volts. So we have 4.5 volts right at that connector. So 4.5 volts is going to the beginning of each resistor. Now, what we have to do is take our 4.5 volts and divide it by each resistor in the parallel circuit. So we'll do the 3 ohm resistor first, which will give us 1.5 amps. And then we have our 4.5 divided by 2, which is 2.25 amps. And we add them together to double check. 1.5 plus 2.25 equals 3.75, which is our total circuit amperage we already calculated prior. So that, yeah, we confirmed that it's right. So we know that our resistor of 3 ohms gives us 1.5 amps. So 1.5 amps is flowing through this circuit, and then 2.25 amps is flowing through this circuit on the parallel circuit side. Okay, I just cleaned it up a little bit so we can work with this circuit and not have to deal with a mess. What we have here, we have a short to ground on right before our resistor in a parallel circuit, but
because it's before on the parallel circuit, it cancels out this circuit, but it would also cancel out this circuit because current flows to the path of least resistance. The best path it'll take is this way. There'll be minute amount of current that travels that way. Something you'll not be able to check with a multimeter or any sort of tool. It's so small. All the current's going to flow to the path of least resistance, which is the path of no resistance. So what this is just a straight series circuit with only one resistor. So we have 12 volts divided by 2 ohms, which is our only resistance, gives us 6 amps. The last thing I want to talk about, how are appliances rated? When we buy appliances, they're rated in watts. Even light bulbs, every equipment we buy is rated in watts. Are they rated for when we first turn on a circuit or when we hold a circuit? Let me elaborate a little bit. When you first turn on a circuit, you will have a lot more current flowing originally than you do when that circuit is stabilized. Are appliances rated for the maximum amount that they see, or are they rated for their average consumption of amperage? Well, they're rated on average. So it is important to understand when you're putting in circuit devices such as fuses, it is important to always go a little bit above what your rated or expected circuit is going to be. Let's say you have a circuit and you're expecting 3 amps. You're not going to put a 3 amp fuse in there. You're going to put a 5 amp fuse in there. It is very important that you always go above the rated amperage you'll see on that circuit, because your first consumption is always going to be higher than your average consumption. And I'll explain why in a later video, but I just wanted to mention that and point that out. This is the part 2 of my vehicle electrical video 2. Thank you guys for watching.